So hello and welcome to this video. Today I want to show you how to build a OPC UA server and client by using a Python module, and we will use the module Python OPC UA. But let's take a look at the project's website. So Python OPC UA is maintained by the freeopcua UA project, and this project offers some open source implementation of the OPC UA stack. For example, they have a C++ library and a Python library for OPC UA server and clients, but they offer some graphical tools for OPC UA related stuff as well. For example, here you can see their graphical OPC UA client with which you can browse the namespace of an OPC UA server, for example. But today I want to show you how to build a server and a client. For this reason I will rebuild the client of my previous videos with Open62541 in Python, but not all, only some parts of it. So today I will write a OPC UA server with the Python OPC UA module, which contains a namespace called room1, and inside this room1 we have a temperature sensor with the three variables vendor name, serial number and the temperature in it, and then we will create another object which I will call light bulb, and the light bulb has a state which we can write values to and read the value out. So let's start. Before starting, make sure you have the Python OPC UA module installed on your laptop or machine. If you're running Linux and you have pip installed, you can just execute the command pip install OPC UA, and this will install the right module on your PC. But as I have already done this, let's jump into the code. A big advantage of using Python is you don't have to compile the code like you have to in C. You can just open up a Python shell and type in your commands and they will be executed immediately, and that's what I'm going to do now. So at first I have to import some modules. They are important for our simulation. And here comes the important part. From the module OPC UA I will import the class server. And the first thing I will do is I will create an object of this class server, and this is our OPC UA server. So at first let's set up the host name and the port number at which the server will be running. We can do this by using the method setEndpoint. In my case, the server will run on the localhost, and we'll use the port 12345. Now let's create a new namespace. We can do this by using the method register namespace, and it takes the name of the namespace as an argument. So the index2 now belongs to the namespace room1. So now here I have saved the objects node in a variable, and I need this because on this mounting point I will add my two objects. So our first object is the temp sensor, and we can add an object by using our mounting point, which is in this case the objects folder, and here, or the objects node, and call the method add object. And this method needs several arguments. One argument is the node, the node ID of the object which should be created, and we have two possibilities. One I will show you here is using string node IDs. In this case, we just have to write the namespace is number 2 and the string is TS1, which stands for temperature sensor 1. Then the second argument is the browse name we want to give, and sensor 1, and the browse name will be temperature sensor 1, and that's it. So now we have created a node with this string node ID. Now we will add some variables here. We can do this by typing the parent node ID of the variable dot add variable is the method, and here we need just the same arguments. We need the node ID, vendor name, but one thing is what we have to give another argument to this, and this is the default value of the node, or the value of the node. Okay, I missed one tick here. So now I've created a new node ID. I will do the same for the serial number. One, two, three, four, five, six, 7, 8 will be the serial number. And now I will create the node for the temperature variable. And I will store this in a variable because I will need it later. And I will set this to 20 degrees. Okay, so now we have added all the also important variable nodes for the object temperature sensor. Now let's create another object, the light bulb. So now object is our mounting point again, the object folder is our mounting point again. And now I will just pass the number of the namespace and then the browse name. So, and as you can see here, this will create a numeric node ID, and it will automatically generate this value. So it will automatically generate the numeric node ID. And here I will add the variable state. But here I will use a string node ID. Or no, let's use a numeric node ID again. Okay, I have to pass a default value as well. False. Now here we can see the state of the light bulb, the node ID of the light bulb, and it automatically increases this value here. And now, because we want to read and to write the state of the light bulb, I will just use the method set writable, and this will set this node ID to be writable from the client side. Okay, now we have put all the nodes into our server, so now let's start the server. But before I will add a variable for the temperature simulation. And we can start the server by using the method start. And that's not like the stop method in Open62541, because this is not a blocking method, so the source code after this will be executed. Okay, now I will begin an endless loop in which I will print out the current value of the node state, and where I will update the value of the temperature sensor's temperature. So I will add a random value in the range minus 1 to 1 to the current temperature, and with the method set value I can set the new value to the node. And I will print out the temperature here so we can see it. With the method get value we can read back the value. And I will print the current state of the light bulb as well. Okay. And we want to update the value every 2 seconds. So, and I can exit from this endless loop by pressing Ctrl C, and after pressing Ctrl C I want to stop the server by using the method stop, and I will print server offline. Okay, so now when I press enter the server should start, and every 2 seconds it will update the temperature and will print out the value of the light bulb. So much for the server. Now let's try to implement the client. From the module OPC UA I will import the class client, and I will create an object of this class. And I have to pass its address and support number under which it can connect to the server. With the method connect, I will connect to the server. Okay, of course the connection was refused because I've typed the wrong IP address. Now it should work. Okay, now I'm connected to the server. With the method getNamespaceArray, I can display all the namespaces which are available on the server, and here we can see our custom namespace called room1. Now I will save the objects node in a variable. And with the method getChildren I can display all the children of a node. So in this case the node object has 3 children. Inside this object a lot of server informations are stored. This node is our temperature sensor, and this node should be our light bulb. So let's save the node of the light bulb node and the temperature sensors node inside two variables. Okay, so the light bulb has one children, which should be the state of the light bulb, and we can display the browse name with the function get browse name. This should be light bulb state or state of light bulb. Okay, that's good. And now if we want to get this value, we can use the method get value, and now we should see the value is false now. And if we want to set the value, we just have to use the method set value, and I will set it to true. So now you can see here the state of the light bulb changed from false to true. Now let's take a look at the children of the temperature sensor. Here we have 3 different children: the vendor name, the serial number, and the current temperature. And now let's take a look at all the values stored in these variable nodes. So the vendor name is Sensor King, the serial number is 1, 2, 3, 4, 5, 6, 7, 8, and the current temperature at this moment was 26 degrees. It should be this value here, or even this value here. Okay, so one option is you can browse through the namespace by using the get children method, but you can directly get the node. For example, I will get the node of the temperature sensor here. I just have to use client.getNode and add the node ID here. So the namespace is second, and the string should be ts1 temperature, and this should return the node as well. So let's check the browse name and the value. Okay, this works. And now if we want to exit the session, if we want to disconnect from the server, we can use the method close session, and this will disconnect the client from the server. And here we can stop the server by pressing Ctrl+C as well. And you see now the server is offline, so everything worked just fine. So this was just a quick overview about the Python OPC UA implementation. I hope you enjoy it, and I hope you recognized that it is very easy to set up a simple OPC UA server with this implementation. I use it if I have to write a simple client or a simple server, and it has to be quick. For this, I think this is a very good implementation and a very usable implementation. So I hope you enjoy the video and you have learned something, and I say thank you for watching, and I will see you in the next video.